Hello, mathletes. Here we are looking at solutions by factorization, and these are solutions to quadratics. So, a quadratic equation is an equation that can be written in the form of ax squared plus bx plus c. We always strive to set it equal to 0. A and b should be constants. That means they should be numbers. We got to make sure a is not equal to 0. If a is equal to 0, then we no longer have a quadratic but a linear equation. Okay, quadratics can have different types of solutions. Meaning, in different types, what I mean is we can have solutions where there's two possible answers. We can have when there's one possible answer or one solution, or sometimes quadratics can have no solutions. So an example here for the quadratic x squared plus 3x minus 10, we can see if we put x into this, x being 2 into this equation, we get 2 squared plus 3 times 2 minus 10. We get 4 plus 6 minus 10 is equal to 0. Okay. Notice also if I plug in negative 5 into the same equation, to the same quadratic, okay, negative 5 squared is a positive 25. 3 times negative 5 is minus 15, minus 10, and that's equal to 0. So we see that we had two distinct values, x equals 2 and x equals 5, where we got a solution of 0. So that is an example of one solution. Well, here, if we just have x squared is equal to 0, well, if x is equal to 0 is our only solution to make that an accurate equal equation. Here, if we think about this, the only way that this can be equal to 0 is if x squared is equal to negative 1. Well, no squared number can ever be negative, so for there is no solutions or 0 solutions for that quadratic type. Okay, so one thing that we're going to utilize here is the null factor law, which states that if you have the product of two or more numbers and that product is 0, then at least one of them must be 0. Okay, so if you have a times b and you have two things multiplying together and it's equal to 0, well, either a must be 0 or b must be 0, and we're going to utilize this in helping us solve quadratics by factorization. Okay, so let's look at the steps involved with solving a quadratic. First, step 1 is always make sure that one side is equal to 0. Okay, after you've arranged your equation so one side is equal to 0, fully factorize it. Okay, apply the null factor law that says what values of x will force your function to be equal to 0. Okay, step 4 is solve the resulting linear equation by, and when we say solve, when are they equal to 0? Okay, so this example here, I have x squared equals 3x. So first thing I'm going to do is I'm going to get 0 on one side. I always like my x squared term to be positive, so I'm going to keep that one on the left side and subtract 3x to both sides. Okay, now I have x squared minus 3x is equal to 0. Okay, so step 1's done. Fully factorize. What do these two terms have in common? Well, they both have an x, so I factor that out, and I get an x minus 3 equal to 0. So that's fully factorized up. Step 2, apply the factoring law. Well, if these two terms, so this is a term here because they're separated by multiplication, and there's a term equal to 0. So either x is equal to 0, okay, or x minus 3 is equal to 0. Well, this one's already solved out, so that's one solution. Or if I add 3 to this and add 3 to this, I get x is equal to 3. That is also a solution as well. Okay, notice I could easily, by just inspection, say, all right, what value do I plug into that equation to be equal to 0? Well, that must mean that x is equal to 3. So this is a solution type of two solutions. Okay, So, one thing that's important to note, we should not be canceling out variables. So if we look at that previous equation, some students might try and say, before setting equal to 0, say, oh, there's an x on the left side and there's an x on the right side, so I could divide that x out. Well, that's all fun and good, but we don't know what x is. The number one rule in math is that we cannot divide by 0. Well, we lose this solution because we know from our previous example that we had a solution where x is equal to 0. Okay, so if you try and divide out a variable in this instance, okay, and you simplify it and you just get x is equal to 3, you somewhat lose the solution that you're talking about. So we must never cancel out a variable that is a common factor. So never divide by a variable, only by constants when solving quadratics. So let's look at another example here. So step number 1, get it equal to 0. So it's positive over here, so I'm going to subtract 28 from both sides. I get x squared plus 3x minus 28 is equal to 0. Okay, so now I have a quadratic that I have to factor with 3 terms. I choose to use the diamond method. So my a value times my c value is negative 28. My b value is 3. So what two numbers multiply to be negative 28 and add to be 3? Well, that's 7 and negative 4. So then I rewrite my middle term using those two factors. Okay, so my new rewriting this above is x squared plus 7x minus 4x minus 28 is equal to 0. Okay, factor out the common factor of the first two terms. That's an x, so I get x plus 7 here. Factor out a negative 4, the two terms here, and I get x plus 7 equals 0. Factor out my common factor. I know I've done this correct because this term is equal to that term. So I factor that out. I get x plus 7. And what's left over is my x minus 4. And this is equal to 0. Okay, so now that I have my two factors equal to 0, either x plus 7 has to be equal to 0, and I see that is when x is equal to negative 7, or I have x minus 4 equal to 0, and that happens when x is equal to 4. So I have my two solutions here of that quadratic. Next example. Okay, so again, this is of the type where we have an a value other than 1. Okay, it's already positive, so I'm going to keep things on the left side. I'm going to go ahead and move these two terms over to the other side by subtraction. So I'm going to get 5x squared minus 3x minus 2 is equal to 0. Okay, employing my diamond method, my a value times my c value is negative 10, and my b value is negative 3. So the two numbers that multiply together to be negative 10 and add to negative 3 is negative 5 and 2. So I rewrite my middle term, 5x squared minus 5x plus 2x. I know that this is an equivalent statement to that. The other two are just writing the same, so I know it's equivalent from here to here. First two terms, look for common factors. Well, it's a 5 and an x, so I'm left with an x minus 1. Next two terms, see that a 2 is a common factor, and then I'm left with an x minus 1. Okay, both these terms have an x minus 1, so I factor that out, and I'm left with 5x plus 2. Okay, now that I've gotten here, I use my null factorization principle. Okay, and so either x minus 1 is equal to 0, which implies that x is equal to positive 1, or 5x plus 2 is equal to 0, and I solve this linear equation, minus 2, get 5x is equal to negative 2 divided by 5, So then I see that x is equal to negative 2 over 5. Okay. So next example here, we can see that this at first does not look like a quadratic equation. Okay? But let's see what happens. So in order to simplify this process, I'm going to cross multiply, and I'm going to multiply these together. And I'm going to get 2 times x minus 2. This is equal to the cross multiplication of these two terms, which is x times the quantity 6 plus x. Remembering my parentheses so everything gets distributed. So I get, as I distribute here, I get 2x minus 4 is equal to 6x plus x squared. Okay, so now notice I do have an x squared term, and I have x terms and a constant. So now, what didn't look like a quadratic before, I have now created a quadratic equation. So now I need to solve it as I do with those first steps. So I'm going to set it equal to 0. X squared is positive on the right, so I'm going to move everything over to the right. So minus 2x plus 4 minus 2x plus 4. So I have an x squared term. 6x minus 2x is a positive 4x plus 4 here. Okay. Things a times c is 4. My b value is 4. So that's 2 and 2. Multiply to 4 and add to 4. So then I get 0 is equal to x squared plus 2x plus 2x plus 4. Factor out a 2. X. Oh, the 2 is not in common, only an x, so I factor out an x. I'm left with x plus 2. Factor out a 2, and here I'm left with an x plus 2. And again, I know I've done it correct because these two are the same, and I get x plus 2 times the quantity of x plus 2. This is all equal to 0. So I see that x has to be equal to negative 2 here. And I get the same solution from this term. So this is a case where I only have one solution from this quadratic. Okay, so remember, we can have two solutions, one solution, or no solution. So this time we get one solution. Okay, last example here. Again, something that does not look like a quadratic initially. Okay, but as I try and simplify this, so I want to combine this fraction here. So in order to add fractions, I need a common denominator. So I'm going to multiply this left side by 1, and I'm going to pick my 1 to be x plus 6 over x plus 6, so it gets that common factor. And then I'm going to multiply the right side by x over x, which is 1, but then I get that factor in the denominator, and then I should be able to add them. So when I simplify this, 1 times the quantity, try and move that up. 1 times the quantity of x plus 6, I'm just going to have x plus 6. And then I have x times the quantity x plus 6 here, plus 4 times x over, and again, it's this x times x plus 6 is equal to 1. So now I have a common denominator. I can go ahead and add up. 4x plus x, so I'm going to get 5x plus 6 over my common denominator. So since they're the same, I'm going to distribute, and I'm going to get x squared plus 6x. This is equal to 1. Okay, so I don't like the fraction, so I'm going to multiply both sides by the denominator. X squared plus 6x, x squared plus 6x. Okay, over here they cancel out, and I'm just left with 5x plus 6 on the left side, which is equal to x squared plus 6x on the right side. So now, again, I have my quadratic. Okay, so now I solve it as I would have from our 4 steps. Set equal to 0, so minus 5x minus 6 minus 5x minus 6. Okay, choosing the right side because my x squared term's already positive. So I get 0 is equal to x squared. 6x minus 5x is 1x. And I have a minus 6. Okay, so a times c is negative 6. My b value is 1. So that gives me negative 3, or positive 3. and then negative 2, multiply to be negative 6, but add to be 1. So I get 0 is equal to, here I can utilize my shortcut because I know my a is equal to 1, where this is just going to be x plus 3 times x minus 2. Okay, so then I solve it. What makes this equal to 0? X plus 3 equal to 0. Well, that's when x is equal to negative 3. And when does x minus 2 equal to 0? Well, that's when x is equal to 2. So then we have our two solutions. Okay, that concludes our notes on solving quadratics by factorization. Highlight any questions you have and bring them to class tomorrow.